All right, welcome to the Explainer. Today, we're going to talk about one single number. A number that, believe it or not, connects the pressure in your car tires all the way to the temperature of a star. It's an absolute cornerstone of chemistry and physics, and you know what? It has a pretty fascinating story. So think about this for a second. How can all these different things, the pressure in that tire, the volume of a party balloon, the temperature of a distant star, how can they all be connected by just one number? It's a puzzle that scientists were scratching their heads over for centuries. Well, the answer is a single, fundamental constant. You can almost think of it like a universal translator for the physical world. Today, we're getting to know this crucial character, the universal gas constant, better known simply as R. Okay, so let's dive right in. What is this universal translator? What exactly is this ideal gas constant, R? And what does it even do? So at its heart, R is something called a proportionality constant. But let's forget the jargon for a sec. Just think of it like a bridge. For a specific amount of stuff, what scientists call a mole, R builds a bridge between the big picture world we can easily measure, like pressure and volume, and the teeny tiny microscopic world of temperature and particle energy. So yeah, you're going to see this number pop up a lot, 8.314 something something. But here's the thing. The real magic isn't in the specific digits. Not at all. It's what that number represents, a totally fundamental, unchanging relationship that's just baked into the fabric of nature. So where did this thing even come from? Was it just some eureka moment in a lab? Well, not exactly. It was more like a whole bunch of brilliant people slowly putting together a giant universal puzzle. You see, R wasn't just invented for fun, it was born out of pure necessity. Scientists had all these different laws that described how gases worked, but they were all separate pieces. They really needed something to tie it all together. I mean, think about it. You've got Boyle's law over here, talking about pressure and volume, Charles's law handling volume and temperature, Avogadro connecting volume and the amount of gas. They were all brilliant, for sure, but they were separate. R is the master key. It's the thing that lets all these laws talk to each other and work together in one single, beautiful, and incredibly powerful equation. All right, now here's where things can get a little, well, confusing. If R is supposed to be universal, why in the world do you see it written with totally different numbers all the time? And the answer is, the constant itself isn't changing one bit. It's all about the units people are using. It's like speaking different languages. A physicist, they might be talking about energy in joules. But a chemist in a lab, they're probably measuring volume in liters and pressure in atmospheres. R just helps translate between them. Exactly. It's the same constant, it's just wearing a different outfit to fit the occasion. And that's what makes it so brilliant and so useful, right? It adapts, making the math way easier no matter what field of science you're in. Okay, but let's strip away all the different outfits, all the different numbers and units. What is R at its absolute core? What does it really mean? To figure that out, we gotta look past the surface and check out its basic structure, or what scientists call its dimensions. Okay, let's break this down. Don't worry, it's not as scary as it looks. We start with the basic formula, right? R equals PV over NT. Simple enough. Now, what's pressure? Well, it's just force divided by area. So let's pop that in. Now, here's the really cool part. Area is just length squared, and volume is length cubed. So when you do the math, a bunch of that length stuff just cancels out. And what are you left with? You're left with force times length. And anybody who's taken a high school physics class knows force times length is the definition of work, or energy. So there it is. That's the big reveal. The gas constant R is really just a measure of work, per degree per mole. It's fundamentally about energy. It's telling you how much energy or work you get when you heat up 1 mole of a gas by 1 single degree. That's its true identity. All right, so now that we know what R really is, let's see it in its natural habitat. Its most famous home, the ideal gas law. Yes, PV equals nRT. This equation is, and I'm not exaggerating, one of the most important equations in all of basic science. It's the reason we can figure out everything from how a hot air balloon works to how much air you need in a scuba tank. And look, right there, smack in the middle, holding the whole thing together, is our hero R. Without it, the equation just falls apart. It wouldn't work. And that's our deep dive into the gas constant, R. It's so much more than just a number in an equation, right? It's a profound statement about how energy, temperature, and matter are all connected. But here's the final twist. The constant is universal for ideal gases. And that leaves us with a huge question. In our messy, real, complicated world, how much of it is truly ideal?